about that cellular makeup and how in the thyroid gland we have what's going to be follicular cells, meaning that in the follicles, the circles, okay, there are going to be cells. And then we mentioned the parafollicular cells, the ones that are going to be in between the follicles, and their materials that they make. So if you remember, in the follicles, that's where we're going to have the thyroid hormone. In the parafollicular cells, this is where we get calcitonin. And the overall job of calcitonin was to affect calcium levels in the body. So that was pretty much the point that we left off yesterday. So this thyroid gland that's pretty unique, but at the same time, the thyroid hormone, that T3 and T4 that gets produced, do you happen to remember like what cells of the body we say that these hormones affect? All of them, okay? So this is a pretty important hormone. So if we begin to look at the structure, it's the bat wings, all right? So it looks just like the shadow they send up into the sky for Batman, all right? Hey, did any of y'all see the movie Batman vs.
That was good. It was really long.
I was like so mad at the end of that movie.
Really?
But anyway, we're not going to spoil it for anybody else.
Okay.
Okay. So, the bat wings. Now, it's connected from one side to the next by this region called an isthmus. Okay? An isthmus. If you remember, one of the things I mentioned is that this is a highly vascularized organ. And they're showing you the blood supply, okay, for this organ. We find it almost at the base of the throat. When you go to the doctor, they stand behind you and they do this number with their fingers coming around like this, and they tell you to swallow. They're kind of feeling for the thyroid gland. Now, the thyroid gland's cells, all right? See how it looks like it's got this empty space, okay? Well, that's going to be one of these follicles, okay, where it's got this space in between. And so these cells that are surrounding that follicle, they're the ones that are giving rise to those thyroid hormones, the T3, T4. These cells that are in between, those are going to be the parafollicular that are giving rise to the calcitonin. Now, when we begin to look at that thyroid gland, all right, those hormones, the ones that are going to be in the follicles, the T3, the T4, the triiodothyronine, or the tetraiodothyronine, or what's commonly known as thyroxine. Now this is kind of important. Transported in the blood, bound. So that tells me that in their transportation around the body, they are going to have a ride. They're going to have to be bound to something. As we move further into our topics, we're going to learn that in the blood, we have these protein complexes called globulins. And that's what they're going to be. They're going to be globs of something, okay? Their job is transport of a substance. So what we're going to see in the bloodstream is we're going to have some thyroxine binding globes. The thyroxine binding globulins. Those globes come from the liver. So the T3 and the T4, remember how I said T4 for the most part is a precursor for T3? Okay? So quite a bit, almost half of the T4 needs to get converted to T3 because T3 is the potent form of this hormone.
Right, thyroxine and that word in front of T4, they're the same thing or just
Yes.
different?
The tetraiodothyronine is also known as thyroxine.
Okay.
Just a shortened way to say it. So, T4, T3. Now, that hormone that's going to get produced, when we have these hormones, the hormones are going to have a target tissue. For example, with the thyroid hormone, it could be target tissue of skeleton, of muscle, right? Okay? And so if we have the muscle cell, all right, and let's just go back to our idea of a cell, okay? Do you guys remember on the cell how that cell has those little receptors on it? Okay? So, hormones. Now, let's go back in our brains a little bit. This membrane, the plasma membrane, what is it made up of? Phospholipids. It's a phospholipid bilayer. Which substance can move freely through this membrane? Lipid substances or water soluble? Lipid substances get to move freely through that membrane. The other hormone, if a hormone is lipid soluble, it can move across the membrane. If a hormone is water soluble, it has to have a receptor. Okay? So, the thyroid hormone binds with intracellular receptor molecules. So if my little thyroid hormone is out here, and this is a receptor for that thyroid hormone, it will accept the thyroid hormone. At this point, what is it that will get activated to affect what takes place in that cell? Do you guys remember what's kind of located? It's a little 3 protein complex. Do you remember what they're termed? The G proteins, okay? The G proteins, all right? Now, you get into like the GTP, the GDP, that's the energy, okay? But if we activate this G protein complex, that third one will go and do something. So, if we can bind that thyroid hormone to this receptor, activate the G protein complex, I'm going to affect what is made by that cell. What is the only thing a cell can make? A protein. So and proteins can function as an enzyme. Is that correct? So now I'm going to affect the product of that cell. So my thyroid hormone can bind, and this, in this case, with the thyroid hormones, initiate new protein synthesis. Am I not affecting now my product that's getting made?
So the thyroid hormone is water soluble.
Yeah. No.
No.
Yeah.
Sometimes.
No. It's special. For our understanding, it's going to have to bind to a receptor. It cannot move through the plasma membrane. So keep that as your understanding for the thyroid hormone. So what can it do? It can go in, and depending upon the cell on which it is acting, all right, it can increase the rate of glucose, fat, protein metabolism. Glucose, fat, protein metabolism. How many of you ate this morning? Increased rate of glucose, fat, protein metabolism. What did your body have to do with the stuff that you ate? And digestion, we got to break it down, right? So, increase the rate of glucose, fat, protein metabolism. This is one of the reasons that the thyroid hormone has the ability to affect body temperature. Because if we have a situation of hyperthyroidism, where we're going to get too much production, we're increasing the rate of that, and therefore affecting the chemical reactions in the body. And if we affect the chemical reactions in the body, that produces more heat and therefore raises body temperature. If it's hypothyroidism, rather than increasing the rate of that, we've done what? Decreased the rate of this, which means we're decreasing the chemical reactions, therefore decreasing the body heat. This is needed for normal growth and maintenance of cells, all cells of the body.
So my grandmother had her thyroid removed completely.
When she had her thyroid removed, as long as she